Hello and welcome to Cat World channel. In this tutorial, we will study about how to carry out the stress analysis if we are having two parts of different materials. Say this part is of SS and this bottom part is of copper, and these two parts are connected by using an M8 size metric thread. So you can see here that the external threads are on SS surface and internal threads will be on copper surface. So we can measure our SS part. This SS part is having a diameter of 15 mm on the main body, and its threaded body we have assumed it to be M8 size. So the M8 for M8 size, its pitch diameter would be 7.2 mm. Okay, so and this is our copper part, which is having an internal thread of M8 and internal diameter is equals to pitch diameter of 7.2 mm. Okay, so we will see the contact analysis. We will suppose that we will fix this top surface of SS and we will apply a load on this copper surface on the bottom surface and in the downward direction. Okay, so we will proceed further toward and we will analyze this contact analysis, threaded contact analysis in ANSYS Workbench. Okay, so we will proceed in the ANSYS Workbench by using the materials. We will assign the materials to both the parts, and you can see here that we are having two parts, copper and SS. Okay, so we will assign the materials inside ANSYS Workbench. We will mesh the two parts using contact controls of meshing as well, and then we will analyze our results inside ANSYS Workbench. Okay, so you can see here that ANSYS Workbench has been opened here, and you can see here that this geometry interface of cryoparametric is opened here. Okay, so we will select this static structural module and drag it and place it here on this geometry interface. And so we have linked this cryoparametric geometric associative interface with this static structural analysis. Okay, so we will double click on this model option, and so it is opening this mechanical module of static structural. So we will mesh the model inside this interface and apply loads, boundary conditions in order to check how the threaded surface responds to force of say 50 kg. Okay, so you can see here that this interface has been opened, and now you can see here that we are having our two materials. The top one is of SS, the bottom is of copper. So first of all, we will check our geometry, this copper part. Okay, now this the material is a structural steel here, so we will, instead of structural steel, we will use copper C10200, which is electrolytic tough pitch copper of 99.9%. Okay, now so this second geometry is of SS, so we will change this material from structural steel to stainless steel 304 annealed. Okay, the second part is you can see here that the contact, because we are using an assembly, so the ANSYS has automatically generated the contact region. You can see here in this split window that the SS part surface has been highlighted here as blue one, and the copper surface, that is the internal threads, has been highlighted here as red surface. Okay, so in this case, for a realistic threaded contact interface, we will change this bonded option to rough. Okay, and you can see here that the contact body is of copper and the target body is of SS. Okay, so we will change this. We will right click and change this option to flip contact target. So we will go to take the contact body of SS and target body of copper, because SS is having more hardness than copper. So you can see here that we will generate the mesh, but we want to use this contact region information. We are going to introduce this contact region information into mesh. So we will drag this information to mesh. So you can see here that we are having a sub control of meshing of contact sizing here as well. Okay, so we will mesh our geometry by right click and generate mesh. So you can see here that a mesh has been generated here, and now you can change this default mesh and generate a more that you can change the element size of this main control of contact sizing according to your requirement. Okay, now we will proceed towards the static structural and boundary conditions. So we will right click on insert, and first of all we will use the top surface as fixed support, and the second boundary condition will be of, we will insert the force of on this bottom copper surface, and we will change this from vector to component, and we are going to apply a force of 500 kg in the downward direction. Okay, so in this case we will use minus. Okay, so we are going to apply a force of 50 kg. Okay, so in the case of newtons, we will the 50 multiplied by 10 would be equal to uh, 500 Newton. Okay, so we are going to apply 500 Newton. Minus sign is for because the force would be applied in the negative direction to the coordinate system. Okay, so in this way you can see a downward force of 50 kg, which would be equals to 500 Newton. Okay, so our information is complete here. So we will select solution and insert first wave. There is a measure of total deformation. Second one, we will use the stress as equivalent von Mises. Okay, so we will proceed further towards solving the solution. So in this way, we are going to check that how because the top surface of this SS part is fixed, and these we are assuming that this interface is of M8 threaded interface between copper and SS, and we are going to apply a downward force in the downward direction. So you can see here that the result has been compiled, and you can see here that the total deformation here is around maybe 3 micron, and equivalent stress is around 35 36 megapascals. Okay, so in this way you can calculate the factor of safety, or you can say that in this way you can estimate the load bearing capacity of a threaded connection of various thread sizes according to their pitch diameters. Okay, so I hope you like this video. So if you want to watch more videos like this, so please subscribe my channel. Thanks for watching.